Well, hello and welcome you to Mr. Robinson back here with yet another brand new exciting video on quadratics. Within quadratic expressions, we've done combining like terms and we've done the distributive property. Now it's time to look at factoring. We're going to look at them in three stages. First one is based on what's called the greatest common factor. It's pretty straightforward. I think you'll make sense of it, especially if you know distribution. It's basically anti-distribution. The next two are on what's called factoring quadratics. They get a little ticky-tacky. I think the first one's going to be pretty easy. Second one gets a little harder because there's so many ways to talk about it. And I'm going to talk about it in the way that will give you the best long-term success. It's not the only way to do it. I have an expansive video on factoring if you ever need to see it. I'll link a description down below when I get to that set. Until then, let's take a look at factoring any polynomial in general, just like if we distribute any polynomial in general. Polynomial factorization. Now, polynomials, guys, are just all these big expressions that have x squareds and x's and things like that. You can't have any square roots with your x's and anything like that. But anyway, all these are called polynomials. Doesn't matter if they're quadratics or cubics or linear or what. But in fact, in factoring these right here, what we're going to do right now is we're going to seek what's called the greatest common factor of a polynomial. And we're going to rewrite this expression so that it's factored out. The greatest common factor of a polynomial is the largest number and or degree of a variable that can be divided out of every term in the expression. And then it's rewritten with the greatest common factor multiplied on the outside of the remaining quotient of the quantity. If the leading term is negative, a negative shall be factored out as well. We'll get to that in 1 second. But what it means is this. When we do an example like 2 times x plus 3, this is distribution, by the way. I'm going to distribute here 2 times x plus 2 times 3. I get 2x plus 6. You saw this example in the previous video here. That way was called distribution. When we multiply something on the outside, something on the inside, distribution. Going that way. Now we're going to be going this way. We're going from 2x plus 6 into 2 times x plus 3. Notice that 2 can multiply, 2 can divide out of 2x, 2 can divide out of 6, and 2 becomes what's in essence the greatest common factor of the x and the 3. So it's kind of an anti-distribution here. That's what factoring is. It is an anti-distribution. So if you want to double check any of your work to make sure that you've done something correctly, you can just distribute back out and see if you get the same answer. If you want to see if you've done it completely, that's a different story, and I'll show you what I mean by that. There's a difference between factoring correctly and factoring completely. Because you might have factored correctly and you can distribute and show you got it back, but if you didn't find the greatest common factor, then you might not be done with your factoring in general. But I think I can get started on this right now. What we're going to ask is, what's the largest number and or variable that can divide with degree that can divide out of every term in your polynomial, and we'll write it as such. Okay, so this first problem, 9x minus 3, I want to ask myself, what is the largest number I can divide out of 9 and 3? And that number is a 3. So a 3 is going to be factored outside of both of these terms here. Can I divide any x's out of this thing here? No, because even though this has an x in it, this does not right here. So it's just going to be the 3 that's factored on the outside. Now what remains on the inside is kind of the distribution step, right? If I distribute a 3 into here, 3 times what gives me 9x is kind of what's being asked. Or do 9x divided by 3, right, the remaining quotient. Do 9x divided by 3, which is 3x. 3 times 3x gives me 9x. 3 times what gives me negative 3? Definitely a negative. Looks like it's going to be negative 1. So this ends up being the factored version of this guy right here. It is correct, and it's actually complete as well. You can kind of ask yourself, is there anything else I can factor out of here? And the answer is no. No more numbers, no more variables. I'm finished with that problem, with that common factor. So that's it. All right, in the next problem here, we have x squared plus 7x. Now remember, x squared also means 1x squared. Now, in seeing that, I cannot factor anything number-wise outside of 1 and 7, besides a 1, but that doesn't count. If you're factoring just a positive 1, then you're not factoring anything because the inside result hasn't changed. A negative 1's a different story. That would change your inside result. However, I can't factor out a number here, but a variable. Can we factor out a variable? This is x squared. That means x times x. 2x is multiplied. And this is an x. That means a single x multiplied. At most, I can factor out one single degree of my x variable. If I factor an x out of here, what remains on the inside? Ask yourself, x times what gives you 1x squared? Remember, you can ignore the 1. Let me ignore the 1 here. I want to kind of be without 1s as often as possible. X times what gives me x squared in x? So in essence, I divide an x out of x squared, and I'm left with x. 7x divided by x is just 7, because x times 7 is 7x. And that ends up being the result of that factored form right there. Again, it's just a greatest common factor of every term in the polynomial. And I want you to note, if nothing can factor out but a positive 1, that means it's not factorable. You just leave it as it is. So if I couldn't factor out anything, I would just leave it as is. In this case, I could factor something out, and I did. All right, last 2 questions right here. And again, these ones are pretty straightforward. I hope these ones are relatively easy in what you're seeing here. Next one, 12t squared minus 60t. I'm going to show you an example of factoring correctly but not completely. Okay, what if you don't know what the greatest common factor of 12 and 60 are? And there are ways to do greatest common factor and break it down in like roots. I'm not going to do all that. But what if you didn't know what numbers could divide out of 12 and 60? What if you knew that, I know I can divide them by 2. I know I can divide them by 2, so I'm going to divide out of 2. So I'm going to start right here. I'll say, okay, if I factor a 2 out, then what you're left with inside here is 6t squared. See if that can make sense. 12t squared divided by 2, or 2 times 6t squared is that. And then minus looks like 30t. Let's ignore that little jingle. Okay, so now if you double check, it ends up being correct, but it's not complete, because you ask yourself, can I factor more out of this inside? Now, this becomes a mess if you don't do the greatest common factor the first time, because you got to remember that the 2 still exists outside here. Just remember that. What about the t? Let's, we forgot to factor out that t as well. Let's make sure to factor out the t. So 2t, and now we have 6t minus 30. Again, there's 1 less degree of t in each term here, right there. Okay. Next one right here is, I can still divide these 2 numbers by 6, right? A 6 can still factor out. So let's factor a 6 out of here. But remember, when I factor a 6 out, it's factored out with the 2 that's outside of here as well. So I got to multiply the 6 that I factor with the 2. 2 times the factored 6 is 12. I just factored out a 6. It multiplied with the 2, and I have 12. And I'm left with t minus 5. So it's smarter and safer and a lot easier to understand and make sense of if you factor out the 12 to start with, or the 12t to start with, so you don't have this confusion of the 2 didn't disappear, it just multiplied with the 6. Plus, you don't run into the issue of, did I factor completely? If you know your greatest common factor of 12 and 60 is 12, then you go straight with that to begin with. And I am done now at this stage. There's nothing else to factor here. You can double check. 12t times t is 12t squared. 12t times negative 5 is negative 60t. And the last problem here, last example, negative 4x squared plus 10x minus 12. We're going to see a lot more with these kinds of problems when it comes to what we are factoring. Just to get this one started here, we're just trying to find greatest common factors. Okay, only greatest common factors, nothing else. Okay, the next video we do, we're going to factor these quadratics to these binomial things, but just what's the greatest common factor here? Okay. Let's look at this first part on the negative aspect. The leading term is negative, and the leading term isn't just by the term that's written in front. It's when it's in standard form, the term with the highest degree. Notice this has degree 2, it's an x squared. This is degree 1. Constants are of degree 0. Remember x to the 0 power is 1? That means it's not written. So this is written in standard form right now. The leading term is the negative 4x squared. If the leading term is negative, guys, please factor out the negative with it. So I'm just going to start by factoring out the negative only. Just make sure you understand that. When you factor out the negative, all the signs change. Negative turns into positive, positive turns into negative, negative turns into positive. Make sure you factor out that negative. Now, I cannot factor out x's from all 3 terms. Doesn't matter that I can factor them out of 2 terms, unless it does, it's got to, let's see, where's my word, every term. Every term. Unless I can do it out of every term, it doesn't apply. Also, for example, I can factor a 4 out of 4x squared and 12, but I can't factor 4 out of 10. So you need to find a number and or variable with degree that factors out of every single term. I can't factor out a 4 out of 10. I can factor a 2 out of 10, though, and 4 and 12. So let's do the 2. No x's, just the 2. And remember, when it factors out, it joins the negative. So let's factor the 2 out with the negative. And when I factor the 2 out, I now have 2x squared. And I now have negative 5x. And I now have positive 6. Now, I would have just done this in one step, but I wanted you to pay attention to the negative portion first and then show you what remains, because sometimes all you can do is factor out a negative, and factoring out a -1 does count as factoring. That doesn't mean it's not factorable. Even if this is all I could stop at, I would write it factored out like this. That's why I'm making sure you see that as well. All right, and that's the final factored form of that one as well. You can, of course, double check and make sure that it distributes back in to do it. Again, factoring is an anti-distribution. This is just greatest common factor only. All right, so that ought to do it for this video, guys. That's actually it. This is Mr. Robinson here. The next two videos are in quadratic factorization. The first one's a lot easier than the second one, but hopefully they both make sense when you see them. Hope you're ready for them. Take care.